All right, well, thanks everyone, and welcome. I apologize that we didn't get to do this talk yesterday, but hopefully it will still be informative for everyone. And I just wanted to take some time to go through all of the different components that App Inventor provides in order to build mapping applications. Now, Maps in App Inventor has the entire section of components that are available for you to use inside of your App Inventor apps. I'll give you a sort of a brief demonstration of all of them, and then what we'll do is I'll build a very simple navigation app using some of them. So the base component that you need to be aware of is the map itself, which is based on OpenStreetMaps. And you just can simply drag and drop it into your user interface. In most cases, you'll probably want to make it fill parent. And it's interactive, so you can, for example, drag and move it around, just as you might expect. You can zoom in and out. We have different tile layers that we can use. So by default, it uses OpenStreetMaps road tile layer, but you can also get aerial footage and terrain maps. So depending on the type of information you want to present to users, one or more of those might be appropriate. If you, by default, it starts at MIT, but you can point it anywhere in the world, either by changing the center from string property in the designer, or you can set the latitude and longitude in the blocks. You can also, if you move the map around and focus on somewhere else, you can press this little crosshair icon and it will set the parameters so that it will always return to that location. So if I move off to the side and then I click the little reset button, it'll bring me back to the center. Reset here. You can also adjust things like the zoom and everything else in the properties as well. Set that back. If you need to move it around, because obviously with it being interactive, it's hard to do the drag and drop functionality if you need to rearrange, but you can, oops, let me do that. You can click this little lock icon to make it so it drags like the App Inventor style, and then you can unlock it to move it around. Now, the first component we're going to talk about is the marker. And so you can drag and drop a marker in, and it gives you this little guy here. And it's quite customizable. You can do things like change the position of the image relative to the actual point that the marker represents by changing the anchor properties. You can give it a title and a description. So title is kind of shown in boldface, and then description is shown in kind of regular face font as part of an info box. So if I put in title, hello world, and you have to enable the info box, you have to check this little option here. If I go over to my emulator and I tap on this, you get a little bubble where you get the hello world and then this message. You can also show the info box programmatically, so even if it's not, like if this is disabled, it won't respond to touch it. But you can programmatically open and close the info box if you want, regardless of the state of this. Most cases, you can have markers be SVGs. The default one is an SVG, and when it's an SVG, you can change the fill and the stroke. So by default, it's got a red fill, but if you wanted to make it green, you could, like so. So in terms of the visual display of the marker, you have a lot of control over that. You can provide your own SVGs as well. Like I have this faucet icon here that I have made. And so, and again, if you have everything at the top level, not specify a fill color or a stroke color, you can it will respect the settings that the App Inventor gives it, which is pretty neat. And I'm just going to rename this for the purposes of the later demo to start pause. You can also let users edit various things. So I can make the marker draggable. And then if I go to my emulator, I can click and hold and I can actually move the marker around the map to reposition it. And there are events that you can use in the blocks to respond to user interaction with the marker. You can also, in the designer, move it around as well. So I can change its position in space and it will update in my emulator. The next component that we have available to us is the line string. So a line string basically represents any sequence of line elements. By default, it just has 2 points. I'm just going to make it a little bit larger for the purposes of the demo. You can again change its color and all that stuff, so very customizable in terms of its display. You can attach a description and a title info box to it. You can make it draggable just like the marker. To edit it inside of the designer, you can actually drag these little handles around to move the endpoints. And then if you want to create multiple segments, you can just drag out the midpoint of each line segment to create more points. And if you want to, you just click on endpoints to delete if you want to collapse the line back down. And for the purposes of the demo learner, I'm going to just call this path. Now, the third item we have is a polygon, which represents a closed area on the map. And by default, it starts off as a triangle, but like the line string, you can move the endpoints and drag the midpoints of the edges to in order to change the shape of the polygon. And again, many of the properties it has allow you to customize the display and the information attached to the polygon. And polygons can be pretty complex. So I'm just going to pull in a feature collection. So a feature collection actually doesn't have any representation within the map itself. Instead, what it does is it acts kind of like an arrangement in order to group related items together. And one of the key things that's pretty cool about the feature collection is you can load resources from elsewhere into it. So I have this usstates.geojson file, and GeoJSON is one interchange format that is used on the web to exchange geographical information. And so this particular file is a map of the United States, and I can select in the source of my feature collection that GeoJSON file. And what it will do is it will actually read the contents in, and for each feature in the map, it will create a corresponding component, right? And so each state is obviously a polygon, and so you end up with a polygon per state. So we could come in here and click on Massachusetts. Let me zoom in. There we go. And it's a polygon just like the polygon I created a couple minutes ago. It's been pre-populated with all of the point data that's necessary to draw the polygon. And just like all the other map components, if we wanted to change it, we can make it blue, we can make it red, could make it empty colored, and then you could give it, a stroke width so that it kind of just shows up sort of the stroke colors. There we go. It's like you can do outlines of things. So like you could outline, say, your city or your town or your state, and do all sorts of stuff like that. Let's just turn that back for now. It's kind of a greenish color. So there are a lot of things that you can do with feature collections. In addition to sources coming from your assets, you can also load URLs and things like that. So if you have a web service that you're talking to that returns GeoJSON, you can actually consume it within the feature collection, which is also pretty neat. Okay, so let's return. Similarly to polygons, we have circles and rectangles. So a rectangle is basically just a polygon, but you can only control the 4 corners of it. And we give you the ability to specify basically the north and south latitudes and the east and west longitudes for the bounds of the rectangle. And then circles have a center point similar to a marker, but then you specify a radius in meters, which you can also do by sort of dragging this little handle to increase or decrease the size of the circle. You could also specify it programmatically. So if you're doing something with the location sensor and you want it to say represent the accuracy of the location data point, you could do something like take the circle, maybe make it half colored like that, and with the say the stroke of blue, and then you could say, oh, the accuracy of your data point around this location is something like that. So you can use it for a lot of different things. So we've also seen people use it for, say, geofencing applications, which is a way of kind of representing a boundary that somebody should stay within. And then you can, when they move outside that boundary, you can, put up a notification or something like that using one of the many extensions that are available to App Inventor. So that covers all the main components that kind of render onto the map. The only one that is more recent and is a non-visible component is the navigation component, which is what we're going to use for our demo. And the navigation component is responsible for allowing you to get routing information from a service called Open Route Service, which is again based on OpenStreetMaps. And so this is a service that you can use. There's like a free plan that gives you a relatively low number of routes. I think it's 7,000 or something per day. You come to this dashboard, you can sign in with GitHub, or you can create an account and you can set up an API key and copy that API key into App Inventor, into the component. It doesn't have a ton of properties that you can manipulate, but one of the more important ones is what transportation method you want it to use when it's creating your routes. So for example, if you were making an app that does something with driving, you wouldn't want to use walking because that might give you sidewalks that go in places you wouldn't be allowed to drive. And there are 4 different types of data that the routing service provides. So you can get directions for walking, driving, cycling, and wheelchair access for if you're doing, say, an accessibility application. And I'm just going to build a very simple navigation app. And all we're going to do is we're just going to display, for starters, the route on the map. And maybe what we'll do also is we'll put the directions up, but let's see how it goes. So I've already got a marker here, which I'm representing as my start position, and I've made it draggable. Let's just reset these 2 things. And I'm going to let the user use that to represent the starting location of their navigation. Likewise, I'm going to add a second marker, and I'm going to make this the end position. And so the green one represents the start and the red one will represent the end. And I also need to make this draggable. And I'm going to make the path invisible for now. Actually, I just realized you probably weren't able to see my emulator before. Let me just share. Can I just share the whole screen? Sorry, one moment. I'm not sure why it's not letting me share my whole screen. That's unfortunate. That's very, very weird. Okay, so if I put up, can someone just send in the chat? You can't see when I bring the emulator up like this, right?
Right.
Why is Zoom doing that? I may just need to kind of switch back and forth. Like if I do that, do you now see the emulator at least?
No, we see this white rectangle, which is much wider than it is high.
Oh, okay. Yeah.
Oh, now I see it.
Okay, great. Yeah, so unfortunately, I guess I'll just have to switch between the two. For some reason, Zoom is not letting me select my entire screen right now. So this is what the app currently looks like. It's not much, but importantly, we can move the starting marker to indicate where we want to start, and we can move the ending marker to indicate where we want to end our navigation. Okay. So let me just make sure that's right. Okay. So now let's go back to our app. The other thing we're going to need, which I forgot to add earlier, is we're going to need a button just to kick off the navigation. I mean, in theory, you could probably do it where every time you move the markers, you automatically compute the route. But given the low number of requests we're allowed per day on the free tier, that's probably a bit overkill. So I'm just going to call this button navigate, and I'm going to make it fill parent and call it navigate for purposes of the code. So this is going to be our starter UI. It's not super complicated, just 6 components, but it should give us a good place to begin our application. And what we're going to want to do is when we click the navigate button, navigation, one of the things we tried to do to make it a little bit easier to work with is, as you saw in the designer, we had properties for the start and stop, beginning and end latitude and longitude, but we also made it so that you could have it interact with map features directly. So there's a end location property that you can use, and there's also a start location property. And for these, you can actually just give it a reference to the marker. And if I copy this, so we're going to have our start location be the starting marker and our end location be the ending marker. And then we actually need to kick it off. So we will call the navigation's request directions method. And because, of course, it's talking to a web service, this is an asynchronous operation in App Inventor, and all of the App Inventor asynchronous operations have a corresponding event handler for when the operation finishes. In the navigation component, that is navigation.getDirections. And we get 4 pieces of information in this event. We get the list of the directions, which are written directions, and you can control the language that the directions come in by providing a language code in the designer. I'm just going to leave it in English for now, and you can reference the Open Route service documentation about what languages they support. It gives you a list of points, the distance in meters, I believe, and the duration in seconds that it estimates the route will take based on, in the case of driving, I think a lot of the routes or a lot of the segments have speed limit information attached to them, and if not, it just kind of estimates. I think for walking, it just kind of assumes you walk about 3 miles an hour, 4.8 kilometers an hour. So for our very basic demo, all we're going to do is this path here represents our line string that we added earlier. We can take the point setter for that, and we're just going to assign our points list from the navigation system to the path. And I also made it invisible to start with, so I have to make it visible as well. And now, if I switch back to my emulator, okay. So now I can drag my markers, and so the green marker is kind of at 77 Mass Ave, roughly, which is the kind of main MIT building. And then if I wanted to say end in Boston Common, I can press navigate, and then I get this line string updated, and it says I should kind of cut through campus, walk along Mem Drive, cross the Longfellow Bridge, and then walk down to down Charles Street to the Common. So, and it didn't take too long to compute that, probably like a second or two, and not bad for a free service. And now we're good to go. We have a very, very simple mapping application. So if you wanted to be able to get directions between two places, you could build something like this and have that available to you on your phone. Now, let's also include the directions. So that's, again, a very somewhat straightforward procedure using something like list view. So I'm just going to go back to the designer, drag in list view, and we'll start it invisible for now. And then when we get the directions, we're going to want to update the list view elements to be the directions. I think I probably want to make this, say, let's have it be 50% high. Otherwise, it might dominate the entire screen. And now if I go back to my emulator, because I updated the UI, it reset everything, but that's all right. If I hit navigate, oh, I forgot to make it visible. Oops. Set to true. And now, excuse me. And now we have written directions that we could use. So you could tie this into, say, a text-to-speech engine, right? So we could actually have the app announce the directions if we wanted to. There's a whole bunch of additional data that the service returns, and we can poke at that in a second. But you get things like turn left, turn right, and so on. Sometimes it knows the names of the streets, sometimes it doesn't. I'm kind of surprised it didn't say anything about Memorial Drive here. And I think, it tends to do better in places where the OpenStreetMap data is more robust. So I think it's probably tends to be more useful in Europe, but still pretty good in the US. If we go and look at the component again, something we don't expose in the event, but we have it available for more advanced developers is the response content. So after you've made a request for directions, you can look at this response content object. No, why did that not? Which basically is the raw response that is sent by the OpenStreet routing service. So, and it uses App Inventor's dictionaries data type to represent the JSON data, and then obviously the list type for JSON arrays. But you can kind of see all the information it includes. So it includes a bounding box. So you could use that, for example, to update the map so that it's only showing the appropriate part of the route. It gives you the list of features that compose the route, and you can see all the coordinates here. These coordinates are basically interpreted as the points variable here. And I'm gonna have to make this much, much bigger. Let's just delete some of this for now. And then it tells you some of the things you do, like all the segments, right? So for each line segment that you have in the display, you could have things like the instructions that it gives, how long that segment is. So if you were trying to build a more robust navigation app, you might want to wait, this minus 2 seconds or something like that before announcing, that you have to turn. And it gives you the distance in meters that it thinks you're going to roughly traveling. Let's see. So that is covered by most of this. And then I think there's just a summary item at the end that basically tells you the total. And these are the distance and duration properties that you get in the event as well. So as you can see, there's a very kind of robust amount of information here that you can make use of in your apps if you want to dive deeper into this particular component. So that's sort of the end of the formal talk. And what I'll do is I'm just going to stop the recording now, and I can take any questions. If people would like to see more kind of demos and things like that, I can kind of just do whatever. And, I'm just hoping that if you are one of the participants in the hackathon and you're doing something with maps, maybe this is giving you some ideas. If you've never done anything with maps before in App Inventor, hopefully in your future projects, this will inspire you and give you some good tools that you have now in your toolkit